bucka. Haha. You know the deal.
The next thing we're going to talk about with exponents is squares and square roots. So here we have a question on the board, and we've seen this type of question before. We would say this is 5 to the power of 2. And to solve this, we would multiply 5 times itself 2 times. 5 is the base, 2 is the exponent. So the exponent tells us to multiply this big number times itself 2 times. And if we were to write that in standard form, the answer to that would be 25. So 5 to the power of 2 is 25. Now, when we see the exponent to the power of 2, there's actually another term we can use for that exponent. Sometimes we say 5 to the power of 2, but we can also say 5 squared. Now, the question is, well, where does that term squared comes from? And chances are it probably has something to do with the square. So suppose we have a square and the length is 5 units and the width is 5 units, because on a square the length and the width are the same. Well, if you were asked to calculate the area of this square, area of a square is calculated by doing length times width. So on a square the length and the width are the same. So in this case, if we wanted to get the area of the square, we would multiply 5 times 5. To get length times width. Well, as we can see here, when we're calculating the area of a square, we're always going to be multiplying one value by itself. So we're multiplying the same value 2 times. Now, we could go ahead and answer this question, but if we wanted to write this in exponential form, 5 times 5 is the same as 5 to the power of 2. So this is why this exponent 2 is often called squared. Because what it's really saying is, well, if this is the length of a square and we square it, we say, well, let's take this length and find the area of the square. But saying all that is a little bit long. So mathematicians tend to just say, well, squared. That's what that means. So here's another example where we're using the exponent 2 or squared, and this time our base is 3. So we would say this question as 3 to the power of 2 or 3 squared. And again, what squared really means is, well, if you have a particular length of a square, which in this case is 3, the length is 3 units, when we square that number, we're finding the area of the square. And to solve that, we would do 3 times 3, because if the length is 3, the width is 3. And then the area would be 9, and the area would be 9 square units. I'm not putting any units in here because we're not dealing with measurement, we're just dealing with an understanding of exponents. So to kind of generalize here, rather than use actual numbers, I'm going to bring some algebra into this. And again, I have a square, and the length here is x. And since the width is the same on a square, I can also call the width x as well. And so to calculate the area of the square, we would multiply length times width. So we would multiply x times x, and here I'm multiplying the same value twice, so we can write that as x to the power of 2. So if our length of a square is x, the area is x to the power of 2, or x squared. Sometimes we're given a square and we know the area. We're told the area, and we have to try to figure out what the length of the side is. So for example, suppose we had a square here, and let's say the area is 36. I'll use some units here. Let's say it's 36 centimeters squared. And a question we might be asked is, well, if the area is 36 centimeters squared, what's the length? So the question is really asking here, well, if this is the length, then this is the length. So to calculate the area of this square, we would multiply length times length. And we know that the answer is 36 because we're told that the area is 36. So we're looking here for two numbers that are the same, that when we multiply them together, the answer is 36. And those two numbers that are the same are 6, because 6 times 6 is 36. So if we have a square where the area is 36 and we're asked for the length is 6, because 6 times 6 is 36. It's kind of lengthy to say what is the length of the square if this is the area. So to kind of shorten that, mathematicians came up with a mathematical operation. And the mathematical operation is called square root. It's actually the opposite of squared. So for this example, we were given the area of the square, and the question is, well, if this is the area, what is the length? The mathematical operation there is square root, and the symbol for square root looks something like this. So this question would be asked as the square root of 36. And again, that's asking, well, if 36 is the area of a square, when we're asking for the square root, what's the length? The length is 6. And the length is 6 because 6 times 6 is 36. If we want to kind of look at this another way, if we're asking for the square root of 36, we're looking for two numbers that are the same, that when we times themselves together, it equals 36. So we're asking for the square root of 6 times 6. Well, since these two values are the same, and we're being asked for the square root, our length is 6. So just a couple of other examples of square roots if you were asked to find the square root of 49. Well, again, that is saying we have a square and the area is 49, and the question is, what is the length of the square? So we're looking for two numbers that are the same, that when we multiply them together, it equals 49. And those two numbers are 7. 7 times 7 is 49. So if we have a square whose area is 49, the length is 7. And that's really what square root means. Now the two examples that I've used so far, 36 and 49, it was somewhat easy to find the answers to those because there is a whole number that when we multiply it times itself, it equals that area. So another example would be if we had a square and the area was 1. We could easily find the square root of 1 because 1 times 1 is 1. If we were asked for the length of a square where the area is 4, that would be an easy one to solve because 2 times 2 is 4. So the square root of 4 would be 2. And then 9 would be the next easy one because 3 times 3 is 9. 16 because 4 times 4 is 16. 25 because 5 times 5 is 25. 36, one we've already done because 6 times 6 is 36. So all of these so far, and there are more, I could go on forever here, but all of these are easy to find the square roots of because the answer is a whole number. These numbers are called perfect squares. And again, the reason they're called perfect squares is because when we do the square root of them, we get a whole number. So for example, if we take 9, if we do the square root of 9, the answer to that is 3. Now, if we're asked to find the square root of a number that's not a perfect square, so for example, if you were asked to find the square root of 24, well, we're looking for two numbers that are exactly the same, that when we multiply them together, they equal 24. And as we can see from our list of perfect squares, that number's not on our list of perfect squares. But what we're going to do is we're going to look for perfect squares that are close to that. And one that's close to that is 25. So we can definitely find the square root of 25. And the one that's closest to that but smaller is 16. So we can find the square root of 16. The square root of 16 is 4 because 4 times 4 is 16. And the square root of 25 is 5 because 5 times 5 is 15. So the answer to this, the square root of 24, it has to be between 4 and 5 somewhere. So it's a decimal. And if we look at this value, 24 is a lot closer to 25 than it is to 16. So if we were to have to guess an answer to this, I would say 4.9 would be a good guess because it's so much closer to 25 than it is to 16. Another example of if we had to find a square root of a number that's not a perfect square, let's take the square root of 90. Well, the two closest perfect squares to that, the one that's bigger than that is 100, because 10 times 10 is 100. So we can find the square root of 100. And the one that's closest to that but smaller is 81, because 9 times 9 is 81. We can find the square root of 81. So the square root of 81 is 9, because 9 times 9 is 81. The square root of 100 is 10, because 10 times 10 is 81. And in this case, we're looking at 90. Now, 90 is pretty close to the middle of 81 and 100. It's a little bit closer to 80, but it's pretty much right in the middle. So I would say that a reasonable guess here would be 9.5. Now, if you have a scientific calculator, you can find the exact answers for the square root of 24 and the square root of 90. I encourage you to do that and see how close my guess was. If you recall this example here where I generalized squares, where we multiply a value times itself, and that means we're calculating the area of a square. If we were given an area of a square and we were told it's x squared, so suppose we said, okay, this is the area of a square, and we wanted to know what the length of the side is. Well, what we're being asked for again, of course, is the square root of x squared. And another way to write that is the square root of x times x. Well, as we saw when I talked about this example, we know the length of the side is x. So the square root of x times x, or the square root of x squared, is x. So what we can observe from this is squared and square root are actually opposite operations. So this is a handy little property when it comes to algebraic equations. As we talked about in algebra, when we're solving an algebraic equation, the goal is to get the variable by itself. So for example, if we have an equation that looks something like this, x squared equals 16. Well, what that means is that the area of a square is 16, because we've taken the length and we've squared it, and we've gotten the answer of 16. But if we're asked to solve this algebraic equation, we're trying to isolate the variable, so we have to get rid of squared. Well, as we can see over here, to get rid of squared, we do the square root. If we square root one side, we have to square root the other side. The square root of x squared is x, and the square root of 16 is 4. And if you remember, our original equation was x squared equals 16. Well, this solution, x equals 4, we know is the correct answer because 4 squared is 16. So we get a situation where the left side equals the right side when we substitute our value for x into that equation. So just to recap, square root and squared are opposite operations. To get rid of squared, we do the square root. To get rid of square root, you would do squared. To finish off our lesson today, I want you to answer a couple of questions. So the question here is to solve the following without the use of a calculator. So for question number 1, we have 12 to the power of 2, or 12 squared. Question number 2 is the square root of 64. Question number 3 is the square root of 50. Now I will tell you that 50 is not a perfect square. So if you're not going to use a calculator here, you're going to have to come up with an estimate. And then the last one, it says x squared equals 225. The question here is to solve, so you have to isolate or solve x in that equation. If you're able to solve those, then congratulations. You should now have a firm understanding of squares and square roots.